This is October-November 2023, paper 1-2. So the first question suggests we want to find out a reasonable estimate. Okay, so which one is not a reasonable estimate? You see, a container ship generally does move at 10 meters per second. Again, I've advised previously as well that you just need to memorize all of these things. Primarily, you can take it from 10 years of past papers and just try to build an estimate from that. An Olympic sprinter, now this is 0.1 kilometers per second, which means if you multiply this with 1,000 because it's kilometers, this becomes 100 meters per second, which is a very unrealistic speed for a person running at any or the highest possible speeds. A racing car moving at 9,000 centimeters, so 9,000 divided by 100 to just convert it into meters per second, right? That becomes 90 meters per second. And this is a reasonable estimate for a racing car. A snail moving at such a slow speed, 0.01 kilometers, is a reasonable estimate. So the one that is not possible or is exaggerated is option B. Which quantity is an SI base unit? He's asking you about the base unit. He's not asking about the unit itself. He's asking about the quantity. Force is found by mass into acceleration, so it's not a base quantity. Newton is a unit, again coming from force, not representing a base quantity. Second is a unit of time. And yes, it is one of the base quantities or a unit of a base quantity, but time is the actual quantity. So we need to understand the difference between the unit and the quantity itself. Similarly, question number 3 requires a bit of mathematical manipulation. First, we want to see what is he trying to find out. He's trying to find out the acceleration by looking at the units of all the options. So I can see that from this equation, I first need to make the acceleration as the subject of the formula. So this is going to be A equals to 2s divided by t square. Now, very easily, I can find the error function as well because I need to find the absolute uncertainty as well. So the error function is going to go something like this. Delta A divided by A, or the problem or the error in A, will be equal to, now since 2 is a constant, that is not the problem. S is being divided by t square. So this will be delta S divided by S plus, invoking the power rule, this means that 2 multiplied by delta T by T. Now, which quantities are the deltas? These are the deltas for every respective quantity, and these are the true quantities themselves. And S is, of course, being represented over here. And this is the value of T. Now, what we can do is simply find out this fractional error first and then multiply with this correct answer. Or you can do it in any other way. So let's put in the values over here. So this is delta S over S. So this would be 0.1 divided by 16.5 plus 2 times 1 divided by 15 seconds, right? Now this is our error function, or you can say fractional uncertainty. Besides this, we want to calculate the true value of A, which is going to be A equals to 2 times S divided by T squared. Now we are going to put in the true value, which is 16.5 and 15. So this is going to be 2 times into 16.5 divided by 15 squared. The value of A comes out as 0.146 meters per second squared, which most likely makes it option C and D, but we need to make sure about the error as well. So continuing our calculations, let's replace 0.16 over here. So this function looks something like this. So delta A divided by 0.146 is equal to this whole function, right? So this will be 0.1 divided by 16.5 plus 2 times 1 becomes 2. So this is 2 divided by 15. Now first you calculate this on the calculator and then take this to the other side, and then you find the absolute error in A to come out as 0.02. So this will be your answer. Option D is the correct answer, as 0.146 is rounded off to two significant figures. I hope that answers your question. Question number 4 is based on the vector components. He says that everything is almost in equilibrium, right? It's moving at a constant speed, which means all the forward components are equal to all the backward components. Now, if you extend this diagram from this situation, you can see that this is the W component, the weight component, and let's make the rest of the vector components as well. Okay, so this is one of the components that comes out as W cos theta, and This is one of the components that comes out as W sine theta. Now, why are we copying this theta over here? This is one of the rules in terms of geometry. You can go check out one of the videos I've used to explain the vector components. In that, I've actually proven that this theta is actually the theta taken at this point. Now, we just need to equate everything to one another. He says we want to find an equation for L and T. So L seems to be equal to W cos theta. So we can very well say straightforward, this is W cos theta. So in whatever equation we can see this W cos theta, I will accept those equations, and where I cannot, I will at least eliminate them. So sine theta is not possible. The next idea, or the next option, comes with satisfying this equation T. Now we can see that T is being held back, or you can say it is being opposed by this component W sine theta, because it is in the same direction, and R, which is also in the same direction, or you can say it's in opposite to the direction of T, or in the same plane. So since it is moving at a constant speed, which means that the forward force should be equal to the backward force, or a combination of all the backward forces. So my thrust is actually not only equal to the air resistance, but it also has to compensate for the component of weight. So this is going to be R plus W sine theta. So I can see that T is R plus W sine theta in option A. So question number 4, option A is the true answer. Question 5, this is a part of our definition. I recommend to the students that whenever you find such questions, pick out the definitions and make them or add them into your notes. So the definition of acceleration is going to be option D as the rate, or the delta V divided by T, right? Or the change in time. The rate of change of displacement is actually velocity. So this is a wrong definition. The rate of change of kinetic energy, which is joules divided by second, which is, say, this becomes watts, or you can say this is actually unit of power. The rate of change of momentum actually goes for force, which is delta P divided by delta T. So only option D was the right answer. Question number 6 is a bit tricky, but let's move on with this. He has given you a certain situation. He hasn't given you the actual velocity. He's given you the components, which is a good thing because we don't have to calculate this on our own. He says that the free fall acceleration, the value of G is 1.62. And what's the speed of the ball after 9 seconds? So we don't know whether the ball is going to be at this location or at this location after 9 seconds. Where it's going to be, I don't know. But what we can do is find out the component of velocity that is affected by gravity. You see, the forward component at any stage of its life will not be affected. So let's say, for the sake of assumption, let's say that the life after 9 seconds of this object is going to be at this location. So the forward force is still going to be 4 meters per second as this one. And since the object is on moon, there is no atmosphere. Now, I don't know whether the velocity still has a positive component or still has a negative component. I don't know that. But to calculate this, what I can do is use an equation of motion which has the component of time available as a part of that equation. The simplest one is V equals to U plus AT. Now, I want to calculate the final speed. I do know the initial speed in the upwards direction, which was 8. So I'm taking this idea. Now, notice that if this is positive, if I am assuming the upward direction to be positive, then I have to take the acceleration as a negative component, which is going to be minus 1.62 multiplied by the time factor, which he has given me, which is going to be 9 seconds, right? Now, when I calculate this automatically, the velocity comes out to be a negative value, which is negative 6.58 meters per second, which means that now I have the absolute guarantee that at certain time, or after 9 seconds, I know this for a fact now, that this is going to be negative 6.58 meters per second. So the ball is actually crossing the halfway mark. It's not before that. Okay. All right. Now at this location, I have the velocity. Now I just need to find out the resultant, which is going to be somewhere in the center. Using Pythagoras theorem, what we can do is find out the resultant velocity as the under root of 4 square plus 6.58 square. When you calculate this, this answer comes out as 7.70 meters per second, which is option B. Right? Okay. Question number 7. This is one of the repeated questions. Very easy question, very easy to solve. No need to worry about this. Okay, so he asks you to find out the frictional force if the acceleration is 2 meters per second square. First, we need to realize where is the friction force. So the friction is only going to be applied in this region because a solid block is in contact with another solid surface. This block, 0.5, is not in contact with anything. In fact, it is only under the influence of gravity, which is mg. Now, according to Newton's second law, the resultant force is going to produce an acceleration in a fixed mass system. Where is the resultant force, right? So we have a friction which is trying to stop the system. We have a weight that is pulling the system, is trying to make sure that the system moves. So I can say that the resultant force will be due to two components. One that is trying to pull the system, which is trying to make sure the system moves, minus the friction, because friction is in the opposite direction, is trying to hold it back, is equal to whatever is the resultant of these two components is going to produce an acceleration in this mass. Now, that mass could be anything, and this is the acceleration we are already given in the question as 2 meters per second square. Let's try to put in the values. So mg, the one that is responsible for pulling it, this is 0.5 multiplied by 9.81, bracket close, minus f is what we don't know, equals to m, this is interesting, and a is 2, which we already know. What mass should I put over here? You can pause the video and think about it. Now, this mass is the mass of the whole system. They are connected by a string. So whatever force or the gravitational force this object brings will not only be utilized by this one, but will also be responsible for pulling this object along. So this mass is not for 0.5, not of 0.2, but the mass of the whole system, which is going to be 0.5 plus 0.2, or 0.7 kg for short. Now you take F over here and bring this bracket over here, then you'll find F, which is going to be 3.51 newtons, which is option A as your correct answer. Now let's move on to question number A. Now please remember that this is one of the questions that is going to get repeated in this way as well. This is a ceiling, right? This is a pulley system. There is a block of mass over here and there's a block of mass over here. What will happen if they're allowed to move? Which one is heavier, which one is smaller? The same equation, the same idea will be applied over there as well. Okay, question number 8 again is a part of definition. It says, and the resultant force causes an object to accelerate. What is equal to the resultant force? Okay, let's explore these things. Acceleration of the object per unit mass. So effectively in English, what he's trying to say is A divided by m. This is not the this is not the resultant force. In fact, in the resultant force, m, a are being multiplied. Changing kinetic energy per unit time. So joules per second again. This is watts. This is not force. Change in momentum of the object per unit time. Now this could be a force that is equal to delta p by delta t. This is one of the forces. The change in velocity of an object per unit time. A change in velocity divided by change in time is actually acceleration. He's asking us about the resultant force. So the option that is the closest representing any force or resultant force for that matter is option C. Moving on to question number 9. He says, now this is a repeated question from free fall and from the topic of terminal velocity. It reaches terminal velocity, okay, from a stationary helicopter, so it doesn't have any initial velocity. The initial velocity is 0 meter per second and it has to fall down, right? What happens to the acceleration? Now we know that initially the acceleration is actually equal to the gravitational acceleration. Now as it encounters drag, eventually it reaches terminal velocity, and when the weight and the drag becomes equal, the gravitational acceleration is 0. Or not the gravitational, but the acceleration of the object is 0. The gravity is still pulling it down, but it's unable to overcome the drag at that point. So it starts from a very high value and then decreases to 0, right? So the value has to decrease. So the very clear option, very clear answer is actually part B. Move on to question number 10. This question also requires a bit of mathematics. So please hold on for this question. He says that the rebound to the left and the velocity is v. What is the loss? Now, when he said that there is a loss of kinetic energy, I can't use the relative speed formula because I know that the relative speed approach is only for elastic collision. If there is an underlying assumption that there is going to be a loss of kinetic energy, that means that this question is going to be an inelastic collision. So you have to take the longer method or the longer mathematical calculation route. You can't use any shortcuts. He tells us that the mass m rebounds with the velocity v. So it goes back after the collision with the velocity v. So what is the velocity of this object? In order to do that, we need to use the idea of momentum before is equal to momentum after collision. So what's the momentum before collision? This is m2v, but in the positive direction. So this is going to be 2 times mv with the positive sign, plus this is 2m coming in towards the left side with a negative sign. So I should add a negative sign with the velocity. I should add a negative sign with the velocity. So this is going to be negative 2mv. Now this whole system is collision, or you can say system before the collision. This is supposed to be equal. Now, even if it's an elastic or inelastic collision, does not matter. The momentums are equal. Okay, so after the collision, he gives me information about one object that it goes back. So it will be considered as negative mv, because now this velocity is towards the left side, plus the mass is still 2m, which is going to be 2m, but this velocity either towards this side or towards this side is not known. So I'm putting this velocity as x. This is x. Okay, now when you solve this, you will realize that this velocity x, or let's call this vx, comes out as v by 2. Or you can say that the velocity that was given to us, this is actually moving towards the right side with a positive sign, half the velocity. Now, I have all the data over here with me. I have the velocities and masses initially and the velocity and masses after the collision. So I can calculate the kinetic energy before and after. Let's calculate the kinetic energy before. So this is kb, kinetic energy before, half mass m and velocity 2v. So this is going to be m into 2v whole square. Be advised, this is 2v whole square, which is going to become 4v square. This is the mathematical mistake that students generally do. And the second part of the object, which is also participating in the kinetic energy, is half into 2m into just simple v square. When you calculate this kb, or the kinetic energy before the system, this is going to come out as 3mv square. Please make sure that you perform the algebra correctly. Now, kinetic energy after the system or after the collision is going to be calculated as v and m. So half mv square simply, and this is v by 2. So this is plus 1 over 2 into its own mass is 2m. So this is 2m into v by 2 whole square. When you simplify this, this comes out as 3 by 4 mv square. Now, to put things even simpler than this, you see this is mv square, this is mv square. These are common throughout all the options. What you can simply do to find just the loss of kinetic energy or the change in kinetic energy is just subtract the fraction. So this is 3 minus 3 by 4. So 3 minus 3 by 4 gives you 9 by 4, which is going to be option C. Moving on to question number 11, very straightforward. He says, find out the moment. So you can do this by two ways, okay? If you want to find out the moment, we need to find out the component that is along this line, because I want to make sure that the distance component and the force component, they're supposed to be at an angle of 90 degrees. So what is this component going to become? This is going to become F cos of 45, right? Or the other way to look at this would be, which is a bit complicated, is to consider this as the standard and then consider this distance to keep the 90 degrees angle. For that, you'll have to take this distance and this will become d cos theta. So one way or the other, d cos 45 to be exact. So one way or the other, you will find that in work done, or the formula of moment, when it is F into d, one of the components, either this one or either this one, will end up with a cos theta function, right? So I would recommend to save time and just visualize it in the simplest format, which is this one, okay? So this becomes FD cos of 45. Now, when you calculate 45 cos 45, you will get your answer on a rational calculator. This should be 1 over under root 2. But you will realize that this is not 1 over under root 2. On the calculator, this will be given as under root 2 over 2. Basically, they try to rationalize it, right? If you go back, this is the true fraction. So that is how he confuses you in this physics paper. So this is going to be 11a, because 1 over under root 2 and under 2 over 2 is exactly the same answer. You can try this by rationalizing the number. How do we do that? We do this by this method, multiplying and dividing with under root 2 and 2. So this becomes under root 2 divided by 2. Okay. All right. Again, a very simple question. He says, what is the torque of the couple? Now, torque means that both forces should be equal in the opposite direction. There needs to be a 90-degree angle. There needs to be a perpendicular distance. Then pick any one of the force and multiply with the distance. So this is going to be FD. No questions asked. Very straightforward. 12C. This is where you save time. Question number 13 is a bit tricky. Just to visualize it is a bit tricky, but let's try to solve this. Okay, so he says that this is the situation where the ball is in and it is being held in this position by the airflow. And there is a weight of 0.15. Okay, so let's redraw this diagram over here. The ball is in, I'm exaggerating this, of course, because we need to draw a few components. Now, this angle is 30 degrees. This is 90. And there is airflow, let's call this FA, from this side. Okay, and there is a component of tension in this direction. Let's make out the other components and see what happens. So this component that is in the upward direction is going to be called t cos of 30. And this component, which is in this direction, can be called as t sine of 30. Okay. Now, of course, some of you might argue, is it not possible that we calculate this using the 60-degree component? Yes, you can do that. This will come out as 60 degrees. And if you want to use that, it's also fine. This will become then t cos of 60, and this will become t sine of 60. Again, you can calculate cos of 30 and sine of 60. You will find that their answers are exactly the same. It does not matter, as I've explained in my vector component video. Okay. All right. So I'm ignoring the 60-degree triangle method. It will give you the same answer anyways. So this is our mg, which is 0.15 newtons, right? I want to find t sine 30 because I know that if the system is in equilibrium, as he mentions, then t sine 30 will be equal to the component of F air. So I know for a fact that force of air is equal to t sine 30. But now here is the problem. The problem is I don't know the value of t because t is the tension. Now to find t, I will use this t cos 30 function against the weight of the component because only that is responsible for keeping up the weight. Once I get the value of tension, I can find out this component as well. This one. Okay. So first we find t cos of 30 being equal to 0.15. We find t through this method and it comes out as 0.173 newtons. Then we put this t over here. This becomes 0.173 sine of 30. When you calculate that, this comes out as 0.0866 Newton, which is very likely and very close to option B. Right? Okay. Question number 14. He says that cylindrical spheres submerged in the liquid. No problem. Objects have the same volume. Very important point. The density of the material of Y is twice the density of material X. So Y is 2 times rho, let's say, and this is single rho. No problem. Both objects are stationary, which means that whatever the weight this object has is being balanced by the upthrust. Whatever this has is being balanced by the upthrust. Okay, fine. Which statement is correct? Now, if we are involving upthrust, we need to write down its formula as well. So upthrust is equal to rho gv. When he says that the volume is same, that means that this variable is not up for discussion. It does not matter because it's same for both of them, although the shapes are different. But if he says, then we have to accept it. And this density is basically the density of the liquid you have poured it in or you've placed it in. If it is a submerged liquid, this rho is representing the density of the liquid, and g is the value of gravitational acceleration. It's same for this one, same for this one. So upthrust basically comes down to the density of the liquid. If density of the object was involved, then I would have worried about these two variables. So it's just a trick question. There is nothing to think about in this question. Let's see what options are going to be correct. A force due to the liquid acting on the top surface of X, this one is greater than the force acting on the top of the surface Y. To tell you the truth, this is inherently a wrong statement because the force on Y is actually greater because it is at a higher depth. So if you apply rho gh for the liquid pressure, Y is experiencing greater force. So A is inherently incorrect. Part B, pressure difference due to liquid top and bottom surface of X is the same as for Y. No, that's not the case. There is a greater pressure difference for rho, but anyways, all right. Then we have question option C. The upthrust acting on X is the same as, yes, this is the correct answer because we know that in the formula, the displaced volume is more important, the density of the liquid is important. And since that's same for both of them, the upthrust is going to be the same. The weight of X is same as the weight of Y. We can't comment about this, probably because this is highly dense. It's very likely that this will have a higher mass, so there will be mass difference between them. So option C is the best one to represent this idea, or the closest one to the true answer. Question number 15. An electric car travels at 70 for 80 kilometers on a straight horizontal, okay, uses energy E. Now, he is giving you the situation to develop a constant. I would recommend not to use the constant at all because that was going to get cancelled out in the second stage of the process. Now, since this is energy, I have speed, I have distance. What am I supposed to do with this, right? So energy has a unit of joules and work done also has a unit of joules. Let's see what happens. He says that the total resistive force acting on the car is proportional to the speed square. So work done is actually force into distance. Okay. And force that he tells me is proportional to speed square. So I can replace this as, or you can say that if F is being proportional to V square, then F is equal to K times V square. Now this is the K that I'm talking about. Either involve this or either don't involve this, it does not matter. So let's involve this because I understand that dealing with proportionality becomes difficult without the constant. So this is going to be K times V square dot D. This is my starting equation. He tells me the speed, he tells me the distance. So my E, which he has mentioned, whatever the value is E, million joules, 2 million joules, I don't know. But whatever this E is basically equal to 70 square K multiplied by 80, which comes out as 392,000 K, because K we don't know, and the unit is joules. I'm writing them separately so that you don't mistake this for kilojoules. Okay. Now we know that E is basically equal to this. Now let's put in this new value. He says that the situation is a bit changed. This electric motor is 100% efficient, so don't involve that. And the speed is now reduced to 60 kilometers, and it is still going to go up to 80 kilometers. Okay. So what's going to happen now? How much energy will it use now? One thing, this is based on estimation, that if you try to move faster, we can see that the drag force is square of speed. If you try to go faster, you will use more energy. If you try to go at a lower speed, you will use less energy. So it is highly impossible that I'm going to use more energy at a lower speed. So option C and D would not be possible, or should not be possible. I'm telling you this idea because when you solve this, and if you get an answer greater than 1, that means you've done something incorrectly. Try to do that again. This is why I'm discussing this estimation with you. Now let's put in the new value. So 60 square into 80. So the new situation, I'm going to do this with a different color. So this is going to be new energy E naught is equal to K times into 60 square into same distance, which is 80. Now this comes out as 288,000 K as a constant and J the unit of that. He wants you to find out the efficiency, right? How much energy is used, how much energy will be used, or what is the fraction of that. So the energy today, which is 288, divided by energy previously, 392. And K, you can see that K over here and over here will be cancelled if you take the ratio. So this is going to be 288,000 K divided by 392,000 K. And if you calculate this, your answer will come out as 0.7346, which is 0.73, or you can say 73 times or 73% of E, or the initial energy. We can see that approximately 37% will be saved if you drive a bit slowly, right? Okay, what is meant by the efficiency of the system? Again, a part of the definition. Nothing can be helped in this. This is option C. Question number 17, he says, okay, so one thing you can see is that just make sure that the units are same. So I can see that the units are same. So now it's just down to the definition that you've memorized. 17 is also a very straightforward question. He says, which is the definition of physical quantity needed to derive this equation? How do you get mgh? So we start with F into D, work done to move a certain distance, or to move from one point to another point in the same direction. So keeping that in mind, a very simple and straightforward situation in this would be, we know G, what G is. So the starting point, acceleration, no, that's not required. Momentum is not required. Power is not required. Work done is, because as mentioned, work done is the starting point of this equation, how we get to this. Okay, now D becomes the change in height. Let's say the object was here, it goes to this side, so this becomes delta H, and the force you applied is actually against the weight, so that is F is mg, and D is the distance or the height that you've moved from one level to another. Question number 18, again we'll have to use shortcuts and tricks to get through this, and to explain it to you over to this, or regarding this, you always compare this with the standard case. You see, this is spring constant K. If you connect the springs in parallel, they become difficult to stretch. So the spring constant is going to get 2 times more difficult. If you connect them in series like this, it's going to get softer. So this is going to be K by 2. And as many as you connect, they're going to keep increasing or keep decreasing similarly. So I can see that over here, this is actually K, this is K, but since you connected them in series, this looks like that this spring is actually K by 2, right? And this is K. And when you connect them in such a way, when they're connected in parallel, you simply add the spring constants. Okay, so this is simply primarily going to go something like this. K plus k by 2, which is 1 plus 1 by 2. So this is going to be 1.5 times k. Okay, let's move to B. As I've mentioned earlier, you just keep on adding them. So this is going to be k, k, k. So this is 3 times k. This is going to be 2k in series with k. So this will be solved in such manner. So this is going to be 1 over 2k plus 1 over k equals to 1 over kt, or you can say product over sum. So very simply, we can see that this is going to be a smaller number than 3, because he's asking us about the largest combined spring constant. I'm still opting for option B, because this number is going to be most definitely less than 3k. So I don't need to solve this further. If you want to do it, I can predict that this is going to be smaller than 3. So I don't need to waste my time. So 3, for 2 springs, we had k by 2. So this will be k by 3, or 0.3 times k. The largest spring constant comes out as option B. Okay. Question number 19. A very straightforward question. Again, no need to waste our time over here. He says Z is the limit of proportionality. Very much clear. The region of elastic deformation is X. So whatever follows this is going to be my answer. So question number 19 is going to be option D, very much so. Question number 20, again, a straightforward question. He says the phase difference between X and Y. Use a ruler and lead pencil to draw a straight line between them. And then you can see that what are the phase differences. You see X, this is 90, this is 180, this is 270, and this will be 360 along one complete wave if you shade it properly. If you shade it, then this is one crest, let's say, and this is one trough. Okay, so one complete wave is being formed and 360 are completed. So between X and Y, there is a phase difference of 270. So this is going to be 270. Okay, question number 21 requires a bit of understanding. He says that this is the displacement. Notice that this is distance, okay? And particle X, now since the wave is moving in this direction, what is next for X? Is it going to go up or is it going to go down? Notice that the next phase in life the particle X is going to experience is coming from this side. This is its past and this is its future. This is where the next instant in life is going to come for X, because the direction of movement of the wave is in this direction. So X is going to go down because this is the phase it is going to experience in the next phase of its life. So X has to move completely down, although X is going to remain at this point. X is not moving forward and backward. The wave is coming towards this direction, as I've explained in the video of waves as well. So what we realize is that X first will encounter a negative phase and then will encounter a positive phase. So first, we will cancel option A and B because they say that particle X will encounter a positive displacement first and then go ahead. So A and B cannot be possible. We have to make a choice between C and D. Now I'm rejecting D on the basis because it's only showing half the picture. I can see that X has to go through whole trough, right? It has to go through the whole process. So the most likely or the closest possible option is going to be option C. First, it goes to the negative cycle, then it goes to the positive cycle of its life. Question number 22. Now again, in this question, you will most likely make the equation, but a quick and smart approach would be to just put all the options in the equation, the calculator, and see what answer matches the situation. You see, the mathematical equation of the scenario is going to become something like this. He says that the frequency is 480, but he's hearing 650, which means that the object is moving towards the observer. So F heard, or you can say F perceived, is equal to F naught, actually produced, speed of sound divided by speed of sound minus the speed of the object. Now, if you put in all the values, this is going to look something like this. So 650 equals to 480 into the speed of sound 340 divided by 340 minus V. Now, he's asking me the speed of the object, right? I can do this by simple mathematical manipulation. I can take this 480 over there, or take the 340 over there, and then multiply, and then do the algebra, and so and so. But I'm sure you must have found by this time that it's, for an A-level student at least, doing this mathematical calculations under the exam pressure becomes difficult. So what I would recommend is that leave this equation as it is, pick out this option A, option B, option C, and option D, and replace them into this equation. from one of the options, at least you will get your answer as 650, which means that this is going to be the answer if you had solved this arithmetically. This technique is called going from answer back to the question. So I've done this for you, and you can see that if you put in these values, what's going to happen. So if you put 89, your answer does come out as 650. So this is my answer. But let's say for the let's solve for the other options as well. So B gives me 741, C gives me 1813 hertz, and 340 gives me an infinite answer, because this will become divided by 0, or 340 divided by 0, which is a math error, which is not possible. And although this is also a mathematically incorrect answer, because we don't know what happens at 0 if you divide anything with 0. But anyways, so the best answer is for 22, option A. Okay, all right. Question number 23, again, I can't help you in this question. You just have to memorize the whole spectrum. I'm really sorry about this, but you have to memorize it. There's no avoiding this. So question number 23 is going to be option C. You just have to memorize it. Question number 24 is interesting. The underlying idea, the underlying problem in this situation is how to calculate this. Now, we know that the equation is I equals to I naught cos square theta. And the incoming filters, their cos square theta factor will get compounded, right? But how to solve this? The underlying assumption, the underlying problem that students, you can say, forget about is that if for the first angle we see that the change is 45 degrees, and for the next one, I realize that the change is 90, right? So that means that there is another change of 45 degrees. So you can't put this change directly. You have to do this one by one. So for the first change, we realize that this is going to be actually a cos square of 45, right? Cos square 45. What is happening in the second change? Now from this situation, it is moving in this line, in this direction, at this point. So there is another change of 45. So this will call for the next compounding of cos square of 45. Now, what students generally do is for the second compounding, they mistakenly put as cos 90, because from the start, the total change has now become 90 degrees. Don't do this. We are looking for the change between the first stage and the second stage. You see, the first stage changed from a 0 degree angle to a 45 angle, right? So we put 45 over here. In the second stage, it changes from 45 and then becomes 90. So there is a change of another 45. So this is going to go like this. So cos square 45 is 1 over 2. Cos square 45 is 1 over 2. This collectively becomes 1 over 4. It's going to be option C. Let's try another implementation. Let's try another question around the same idea. What would we do then? For example, first change is 45, and then he tells you that the next angle is approximately from the original situation is 65. What would you do then? So first stage would require a cos square 45. That's true. That's done. But how to tackle the 65? Should I put cos square 65, or should I put the change from stage 1 to stage 2? I can see that the change is about 20 degrees. So this is going to be cos square of 20 if that had been the question. So always look for the change between the stages and then keep on compounding the changing polarizations or the degree of polarization. Okay, that's the trick for this question. Question number 25, you have to memorize this in some sense, but let's explore all the options. It says, how stationary waves are formed from progressive waves. We know that stationary waves, there is a primary wave moving towards some surface, it bounces back, and then it produces a reflecting wave like this. So when these both waves meet at a point, they keep on crossing through each other, right? The result of that produces a stationary wave. So let's see what's happening. So does diffraction explain this behavior? No, diffraction explains the spreading of wavefronts and becoming a circular wavefront. Does polarization explain it? You see, polarization is about filtration, okay? Stationary waves don't have to do anything with that, okay? Can superposition help it? Most likely, a superposition is what happens when both waves are actually moving towards each other. They get added into each other, and as a result, whatever wave is formed is because of superposition. So most likely my answer should be C. But let's move to the next answer. Doppler effect. No, Doppler effect is not responsible for stationary waves. Doppler effect is responsible for change of frequency. So my most accurate or the closest answer is going to be option C. Question number 26. Very simple, very straightforward. A breath of fresh air at least. So let's make the stationary wave at this point. So this is going to go something like this, then this, and this. And the opposing stationary wave, or the next phase of the stationary wave, is going to go something like this. Okay, so now it's a matter of counting the wavelengths. So this is going to be from this point to this point 1 lambda, from this point to this point lambda by 2, from this point to this point lambda by 4. Just add all of them together. You can use a calculator to do that. So this is going to be 1 plus 0.5 plus 0.25. You'll get a fraction. Your fraction is going to come out probably, whatever the fraction is, this is going to be equal to 2, right? And then lambda is common on the outside, so just take the whole fraction on the other side. This is going to come out as 1.142 meters. So this is going to be 1.1, which is B. Question number 27, he says, a teacher explaining diffraction to a group of students. Which piece of data is more appropriate for demonstration of diffraction? Okay. A long spring, not really. It doesn't do anything. A ripple tank, most likely yes. Because we want to represent diffraction, so what we can do is that if this is a ripple tank, for example, filled with water, let's say, right? So we can place two gaps like this, and we can have an oscillator over here, which will be generating parallel wavefronts, and when it crosses this narrow gap, the wavefronts become circular. So this is very possible. A rope, no. Not possible with a rope to represent diffraction. A stretched spring, not really. Again, no, it doesn't do anything. So the correct answer would be option B in this format. Primarily, this is how they actually discovered what diffraction was. They were experimenting with the water waves, and they realized that when you pass it through a narrow gap, it becomes circular wavefront, which is peculiar. Okay, so question number 28. Again, you have to deal with the mathematical equation. He says this is a double slit experiment, so this is going to be AX equals to lambda D. Now let's see what he is trying to change. He says that the separation of the slits is being varied. Now slit separation is being varied. He says A and X. Now from this equation, let's make A or X a subject of the formula. It does not matter. Now since X is on the y-axis, let's keep that on the left side, and let's bring everything on the other side. So lambda D divided by A. Now, since these are constant, I'm left with X being inversely proportional to this. This is a classic behavior of inverse proportionality, and I know from previous mathematical knowledge that this graph of Y and X is actually going to go like this. You've also done this graph in the Boyle's law, which is pressure is inversely proportional to volume. You may remember that that graph is also drawn like this. So it is not physics, it's actually a mathematical issue. It's actually a mathematical point that the inverse proportionality is always going to be drawn like this. Now, so I will choose a graph that goes like this, that goes a bit like this, which is very closely resembling what you could say is being copied in option A. So option A is the correct answer. Question number 29, a good question in terms of diffraction grating, and it revises a lot of concepts that we've done before. How to put this number as a quick reference in the equation. Let's try to do that. So he's asking you the maximum number or the total number of bright spots. So he's primarily asking you how many maximas are going to be produced. Okay, so let's try to do that. So n lambda equals to d sine theta. Now first, if he's looking for the total number, the maximum number of maximas, then we have to put sine as 90, because we're expecting that one of the bright spots is going to show up here, some of them will show up here, over here, over here, over here, so on and so forth. So we are deliberately pushing this equation to its maximum limit. That is there anything compared to the center? Is there anything at 90 degrees? So be it. Let's move ahead with this equation. N is what we want to find out. Lambda is given as 690. So please be careful. 690 to 10 raised to the power minus 9 into D. What to do with D? D is this value. How to put this? A very straightforward shortcut is, if he's given you per millimeter, put this millimeter at the numerator and the number in the denominator. Now we will deal with this like this. 1 into 10 raised to the power minus 3 divided by 300. Let's put that T over here. So this is 1 into 10 raised to the power minus 3 divided by 300. Now sine 90 is 1. So that is going to be 1. I find N as a decimal number, which is 4.83. Now this has to be a specific number. This has to be an integer. It can't be 4.8. It has to be either 4. It has to be either 5. Now, although this is wrong theory, which I'm going to say right now, it means that the fourth order diffraction is somewhere here. Let's say n equals to 4 was here, And exactly at 90, compared with the center, the n equal to 0, exactly at 90, we saw n equals to 4.83. Now, in reality, there is not, you will not observe anything at 4.83. You will not observe anything at 90, which means that your last maximum possible order that you would be able to see is going to exist at 4. And if you want to observe 5, then that would have been greater than 90, which is impossible. N equals to 5 will not be formed in any capacity, which means that we have to come down to 4. So these numbers, despite being 4.8, rounded up should be 5, but it's not going to be the case because there is a physical problem attached to it. So these numbers always have to be rounded down for the absolute maximum, for the absolute best. So the largest order I'm going to see is going to be n equals to 4. So n equals to 4 on this side, which means 4 bright spots, and 4 bright spots on this side, on both sides. So 4 plus 4 is 8 bright spots. Now notice how he confuses you. He's mentioned 8, but is that the right answer? No, the right answer is 9. Why? Because you forgot to count the bright spot at the center. So this will be 4 plus 4 plus 1. So 9 bright spots are being observed. Option D is the correct answer. What you can do as an exercise is choose n equals to 4 and calculate sine theta. No, you can do this. So n lambda equals to d sine theta. This is going to be 4. This is going to be 690 into 10 raised to power minus 9. This is going to be 1 into 10 raised to power minus 3 divided by 300. And this is going to be sine theta. Calculate the sine theta and you will see that it's going to be less than 90, which means that 4.83, which we found previously, is not possible. It won't be possible. But we put in sine 90 to theoretically and mathematically push this equation to in a situation of exaggeration. What would happen? What would ज़्यादा से ज़्यादा क्या हो जाएगा? ठीक है? So this is the logic behind solving it this way. Okay. Okay. Question number 30. As explained earlier, this is a concept of quantization, and you will see this word explicitly written in your electricity syllabus. He says which one is not possible. You see, an object is charged. What is not possible? Can it have a zero charge? Yes, it can have a zero charge, or it can have no charge at all. It's possible. Can it have this? Can it have this? Can it have this? So how to do this? We know that the elementary charge has to be a multiple of 1.6 power minus 19. I can see that all the options are having minus 19 in their power, so I can ignore this minus 19 from at least my mathematical checking. I don't need to involve 10 raised to power minus 19, right? So now is the right time to do this mathematical check. You see, 1 divided by 1.6 should produce an integer number, should produce a whole number, because an elementary charge means that the charge can be a multiple of this, 2 times, 3 times, 4 times. It can't be a decimal multiple. For example, 2.1 times or 2.7 times. It can't be this way. This is called quantization, right? So when you divide 4.8 with 1.6, the answer comes out as 3 charges or 3 coulombs of charge. If you divide 8 with 1.6, the answer is 5 coulomb of charges. So this is a whole number integer. This is an integer whole number. These both options are possible. 0 is possible. What is not possible is a fraction or a decimal answer, which is option B. So again, you can see that he's frequently testing quantization concept in the recent past papers. Question number 31 involves mathematical concept. He says they're connected in series. Okay, fine. The power dissipated resistor X is this much. Okay. The current through it is 3. Now, since they're connected in series, the current in the variable resistor would also be the same. The variable resistor, just as the power of X increases by 50%, which means that if it was previously 7.2, now it's going to be 1.5 times more. He says, what's the new current in the circuit? Okay, let's try to do that. So we have P equals to I square R, right? So this is a 7.2 equals to 3 times square into R, which is going to, R is going to be the constant. If you don't want to do it this way, you know that this R of X is constant in both systems, in both situations, because this is the variable resistor. This is a fixed resistor. We're not changing its resistance at least. So we are only interested to find out the change in power or change in current in the circuit because of the fixed resistor. Although, of course, the current, since it is going to go through both resistors, whatever effect has been produced by the first resistor or the second one will be reflected on the whole circuit as well, equally well. So let's do it this way. Okay, you can either find R and put this into a new situation, which would have been something like this, that R is equal to 7.2 divided by 3 square. Let's keep it this way. the new situation requires, let's say, P dash equals to I square R. Now, what have we done to the resistance? We don't know, okay? But we have changed it in such a way that the power is now 1.50% more. So this is going to be 1.5 into 7.2 equals to I square, which is what I don't know. R previously was 7.2. So 7.2 divided by 3 square. Now when you calculate, don't forget the under root over the other side. When you take this over this side, you realize that I comes out as 3.67 amperes. What you could have done alternatively, because you know that R is a constant, right? You can compare these two equations directly by eliminating R. What you could have done is P1 divided by P2 equals to I1 squared divided by I2 square. This is a simple mathematical technique, okay? Again, if you realize this whole setup is actually, you can say, a representation of this equation, okay? What you could have done is simply take this 1.5 into 7.2 divided by 7.2 equals to I square, or you can say IX square divided by 3 square. When you solve this, again, you're going to get 3.67. Anyways, that's up to you, what you are comfortable with, what mathematics you're comfortable with. 32 requires a bit of mathematical manipulation. He wants you to see whether you can reach that conclusion. He says the length is L, the diameter is D, and how the current in the wire is related to L and D. So V equals to IR is the equation. We want to find current. So let's make current the sub of the formula. So this is going to be V divided by R. And we know that R is equal to rho L over A. He's mentioned that L and D are already given. Okay. So we can see that rho is not a problem. So we can eliminate that. So L is small l divided by A. Now A is equal to pi times D squared by 4. So A is proportional to D square. I can replace D square in place of A. Just a simple switching of variables or representatives. So now I know that R is equal to L divided by D square. Now let's replace R over here. What do we get? We get I equals to V divided by L divided by D square. D square goes to the numerator. So this comes out as D square V divided by L, which is equals to current I. So I can see that I is being proportional to D squared divided by L. So what equation represents this? What theoretical answer gets close to this? So yes, inversely proportional to L, directly proportional to D squared. This is the answer. Directly proportional to D squared, inversely proportional to L. D will be the answer. Okay, so in this question, he says that we want the voltmeter reading to decrease. He tells us that the voltage terminal, this is positive, and the voltage reading is also positive, which means that this terminal is at a higher voltage, this is negative, this terminal is at lower voltage. For example, this was a 10-volt battery. It's possible that this is at 8 volts and it is, let's say this one is at 5 volts. So the potential difference shown on the voltmeter would be 8 minus 5 as 3 volts. We want to decrease this gap. We want to make this 8, then 7, then 6, then 5. Or ideally, if this keeps on decreasing from 8, 7, 6, this should increase to 5, then 5.5, then eventually 6. When this reaches 6, this also becomes 6. The potential difference becomes 0. This is what he wants to do, that the potential difference or the difference between the voltages at both terminals should exactly be the same, or at least the difference between them should decrease. The second idea we need to understand is that both these branches are connected in series to each other at least. They're in parallel in this way, but they're in series with each other with their respective fixed resistor. So what do I want? I want this voltage terminal to produce less voltage, which means I want this resistor to consume more voltage and this resistor to consume lesser voltage. So how can I do that? By decreasing its resistance. And how to decrease the resistance of a thermistor? They are inversely proportional to temperature. So to decrease the resistance, right, I need to increase the temperature. So temperature has to be increased. Now, again, there are no other options given, but for the sake of science, we are going to discuss the rest of the situation as well. Now, over here, in order to bring this voltage back up again, what I want is to reduce the resistance, right? So I want to reduce the resistance of LDR so that if I'm getting, let's say, 10 volts, if I'm sending 10 volts, I want maximum voltage to show up here. So I want the LDR to use less voltage. So that if this was 10, and previously in my example, if this was 5, I want to rise it up to 6. Then of course, I'll have to ask the LDR to use less voltage so that more voltage can show up at this point, at this node. So how can I reduce the resistance? So decreasing the resistance again is an inverse relation with light. Light intensity has to be increased. So light intensity has to increase. So this is going to be option A. Okay. Question number 34 is option, let's see. Again, this is a part of definitions. The question statement, he says EMF across each resistor, potential difference across the battery. You see, EMF word is not for the resistors, it's for the battery, and potential difference is for the resistors, not for the battery. So he's used incorrect words for incorrect components. Potential difference across a resistor is equal to the EMF E of the battery. This seems like a good answer. Across, no, not across each resistor. So this is V1, V2, V3, and V4. They're not individually equal to this. Their sum is equal to that. So there is an inherent flaw in this statement. The sum of EMFs, again, EMF for the resistors is not the right answer. The sum of potential differences is equal to the, yes, this is the most accurate statement. Again, a part of definition, Kirchhoff's second law, that all EMFs are equal to all potential differences. Kirchhoff's law, conservation of which physical quantity? So it's the first law, it's going to be charge, because that's for the current. Again, a part of definition, part of memory. Question 36, it says each resistor is 6 ohms. What's the final resistance? You'll have to use the shortcut. I've explained it in previous videos as well, that if you have an identical resistor, then you can simply divide it by the number of resistances in that parallel combination. So if these are 3 resistors, they're primarily 6 divided by 3. Or if you want to go through the long method, it will be 1 over 6 plus 1 over 6 plus 1 over 6 equals to 1 over r. Now notice when you simplify this is going to be 3 by 6 by LCM method, and this is going to be 1 over r. You cross multiply this, and this is going to be 3r equals to 6. Then r equals to 6 by 3. This is what I am telling you. So use the shortcut. If you know that the resistances are identical, then don't need to go through the long method. Just use the shortcut. So this is going to be 6 by 3. Now these are 6 resistors. This will be 6 by 6, which can be equated as 1. Again, this is 6 by 3. Simply add them together because they're all connected in series or a single circuit. So this is going to be 6 by 3 plus 1 or plus 6 by 3. So this is going to be 2 plus 1 plus 2. This is going to be 5 ohms, which is going to be option B up to 2 significant figures. This is 36A. Sorry, 36B. 37, he says it's the unknown cell method, or you can say the null method formula. He says that the circuit shown the battery negligible internal resistance. Okay, good thing. With a series pair, okay, R1 and R2. 6 volt battery. Let's figure out what's the EMF at this point. So voltage divider rule, we have 20, this one, divided by the total resistance, which is 20 plus 60. So this is going to be 80 multiplied by the battery, the voltage that is going to divide it into the 2 resistors. So this is going to be 6, which comes out as 1.5 volts. It means that between these terminals, there is a 1.5 voltage drop because of that resistor. Now, whatever EMF of the cell there may be, this is going to be 1.5 volts, and this is going to consume 4.5, the rest of the battery. If you add them together, this is going to get 6 volts back again, right? Okay, the circuit is used to test whether the electromotive force, EMF, of a particular cell is 1.5. We want to check whether this cell is 1.5 or not. The cell is connected between X and Y, and notice that this is the positive terminal, this is the positive. The positive terminal has to be connected with the positive for the unknown cell. Which statement about the test is correct? A non-zero reading on the galvanometer? No. It should be a 0 reading. Either an ammeter or either a voltmeter. It should be a 0 reading. The battery does not need to share. No, the battery needs to have a voltage higher than our expectation. It should have been 6, could be 5, could be 4, could be 3, could be 2. But it cannot be less than 1.5, cannot be less than the testing cell EMF that we're using. So because we don't know what the EMF is, so it's always a good idea to have this voltage much, much higher than what you're expecting. The cell may be connected in either way. No, we can't connect it either way. If this is the positive terminal, then the starting cell or the starting or the connecting point of the cell should also be positive. The galvanometer does not need a scale calibrated in amperes. It could have been in volts, it could have been in microamperes, milliamperes, but it needs to show a zero reading. If it shows a zero reading, it means that the voltage at this node and the voltage of the cell is exactly the same. There is no potential difference and there is no current. So 37D is the correct answer, right? It does not need to be calibrated in amperes. It could be volts, could be milliamperes, could be microamperes. 38, based on memory, he says, what's the definition of an isotope? You can read all the options, and I hope understand that 38 is going to be option A. Question number 39, a question based on mathematics. It says charge to mass ratio of alpha, beta, and proton. You see, for alpha, we have 2 protons and 2 neutrons. And only because of the protons, we have a positive charge. So for a proton, so alpha charge divided by mass would look something like this. 2 multiplied by 1.6 into 10 raised to the power minus 19 divided by 4 times the particle's mass. So let's take the standard atomic mass units. This is going to be 4 multiplied by 1.66 into 10 raised to the power minus 27 kg. This is charge Q. Okay, this is for alpha. Now for beta, it is going to be 1 elementary charge, 1 into 10 raised to the power minus 19, although a negative sign because it's a negative charge object, although it's a positive positron, so it's plus, although it doesn't matter, divided by the mass of the electron is given in data booklet as 9.11 minus 31 kilograms. Then we have a proton. So proton will have 1 elementary charge, which is 1.6 into 10 raised to the power minus 19, divided by 1 its own mass, which is 1.67 into 10 raised to the power minus 27 kg. Now you can very well see which one will have the highest answer. You see, minus 31 and minus 27 have a difference of at least 2,000 times. So he says increasing order from left to right. So the largest answer should be of the beta positive. Okay, so beta is the largest answer, or should be the largest answer. Or what you can do, use your calculator and solve them. I'm just making a guess over here, right? The next in line should be, or smaller than beta, should be the proton. Yeah, because this is 1 times minus 19 divided by 1 times minus 27. This is 2 times the charge, but 4 times the mass. So alpha is going to be the smallest. So this should be smallest, medium, and largest. So 39 should be option B. Or counterintuitively, you can use a calculator, calculate all of them. Question 40, again from memory, very straightforward question. He says neutron, it's a neutral charge. So this is going to be up, down, down. We remember this from memory. This is going to be up, down, down, option C. You can try this because up has plus 2 by 3e, down has minus 1 by 3e, down again has minus 1 by 3e. So up, down, down gives you 0 overall. This is the neutron.